We can use the principle of conservation of momentum to work out how particles will behave after a collision. The key thing to realise is that momentum is a vector quantity, so direction is important. Let's consider 3 examples. In example 1, 2 particles of the same mass are heading towards each other at equal and opposite velocities v. After the collision, the first particle has 0 velocity. What's the velocity x of the second particle? Well, the momentum before is mv minus mv is 0. So the momentum after is 0 plus mx equals 0. So x equals 0. The second particle comes to rest too. In example 2, 2 particles of the same mass are heading towards each other at equal and opposite velocities v. After the collision, the first particle has velocity minus v. What's the velocity of the second particle? Well, again, momentum before is mv minus mv equals 0. So the momentum after is also 0 and is minus mv plus mx equals 0. So that means x must equal v. Both particles bounce off each other and reverse direction and velocity. Finally, in example 3, both particles are at rest before. Afterwards, the first particle has velocity minus v. What's the velocity of the second particle? Well, momentum before equals 0. Momentum after is mx minus mv equals 0. So that means x is equal to v. The particles fly apart with equal and opposite velocities. These are all very similar examples, but with very different particle behaviour. In example 1, the particles came to rest. They appear to lose all their energy. In example 2, they bounce off each other. Their energy stays the same. In example 3, they seem to gain their energy from somewhere. We can work out kinetic energy. It's equal to a half mv squared. So that in example 1, the kinetic energy before is mv squared. The kinetic energy afterwards is 0. We call this an inelastic collision. In example 2, the energy before is mv squared. And the energy afterwards is also mv squared. We call this an elastic collision. In example 3, the energy before is 0. And the energy afterwards is mv squared. In each case, momentum is conserved.